Hello, I'm going to do 225 and 226. Now, again, these are multiple choice questions, but I'm going to pretend as if they were free response questions because I've got 2 more days till the test itself, and I want you preparing for both pieces of the test. So I notice I have 2 categorical pieces of data. And this would be a 2x5 table. And this is my raw data. So immediately you should be thinking, this is a chi-squared, and I have a goodness of fit test for chi-squared, or I have a test for homogeneity or a test for association, which is also called, this is the chi-squared test for an association. So this is definitely my answer, but now I'm going to actually perform it on this question. Notice they didn't total these up, but the grand total here would be 275. But we don't need to do that for the question. If this was my free response question, I would state that we are going to be preparing a chi-squared test for independence. I have my H sub O, and that is that it says what would be H sub O would be there's no association between vehicle type and vehicle color. And so that's what they're trying to figure out, is that if I know the vehicle type, like if I know that it's a Ford Mustang, does it have more likelihood to be black or red, you know? And I think we think that there is. I think certain cars you see in certain colors. But we can't just have a hunch, we have to prove it. So of course our null hypothesis would be that there is no association, and our alternate hypothesis is that there is an association between the vehicle type and color. So to prove this, we need to pull up our calculator and name our test. So I'm just going to name this vehicular. We put an equal sign, and so you have to hit control boxes and then boxes again, and you want a 2x5 table here, and you're going to insert the 10 pieces of raw data. All right, and so we're going to do that. We're going to scroll down here, and we said we were going to name our matrix VHI vehicle. I'm just going to spell part of it, and then I want to hit control boxes and boxes again, and I have to pick a 3x3 and customize this. So it looks like I have 2 rows and 5, and I'm going to hit enter, and now I'm going to put this raw data from my problem in. 35, 23, 41, 21, 12, 27, 55, 39, 12, 10. Now I hit enter just to make sure that the calculator got my information, and this is a great time to just double cross-check that you didn't type anything wrong. Now I want to hit menu, go down to statistics, and notice that I'm doing a stat test, which is a chi-squared 2-way test. The calculator doesn't really know the difference, nor do a lot of us, between homogeneity or an association. So it's the same type of test in the calculator. We named it vehic, and we hit enter. And notice all this, if it was a free response question, would go on my page. I'd list my chi-squared value. I'd list my p-value. I'd list my degree of freedom. Now in my state plan do conclude, I still have R and I, and you want to make sure that they're independent. Something random about the study. It does say it was a random sample. And for N, you're actually looking at these expected counts, and you need your expected values to be greater than or equal to 5, not 10, not 30, greater than or equal to 5. So to do that, you actually hit this var button and you scroll down to the expected counts, hit enter, and notice that all of these numbers are greater than or equal to 5. So you would say that in words, all expected counts are greater than or equal to 5. Boom. Okay? And you talk about them being independent. Now, notice I got an extremely low p-value, so you are going to reject the null hypothesis. We do have sufficient evidence to conclude H sub A, and of course, H sub A is that there is an association between vehicle type and color. So our hunch was right. We believed that knowing the truck's type or the car's type would help me predict the color. And it's because this p-value was less than our significance level, which is 0.05. And of course, 200ths is much less than 500ths. 2,000ths, excuse me, is less than 500ths. So that's basically it. Again, though, you want to rack up all these points on this question. Now let's look at 226. It's one of these, what I call the devil questions. It says, a large number of randomized experiments were conducted to determine whether or not a particular drug would decrease the chance of getting a certain disease. For the experiment, the drug calculated the difference. So you either get the disease or you don't. So this is a proportion question. And it says, is there a difference in the proportion? We calculate it by taking the proportion of people that took the drug, subtract that from the proportion of people who took the placebo. Now they actually jumped to the conclusion that the H sub O that would be that there is no difference, and H sub A, I believe you would hope that the proportion of people that got the disease you'd hope would be less than the placebo if it worked. Now they're ultimately having you pretend that you finished the experiment. What would the experiment outcome look like if in fact the drug had absolutely no effect? So if the proportion was absolutely the same, then it would just be like flipping a coin. You would have one might be better than the other on any given day just based on general variability. So the p-value would be greater than 0.05 for about 95% of the experiments. And that's absolutely true. If in fact H sub O is true, that's exactly what we'd get if they were totally exactly the same. Now, the next one says, so I'm eliminating those. The next one says there would be about an equal number of positive and negative values. And that's true as well. If these are exactly the same, half the time more people would have the disease with the drug than without. It would be probably even amounts because, again, it would be like flipping a coin. Half the time, if you do it a whole bunch of times, half the time you get more heads than tails, half the time you get more tails than heads. So this also would be true. So you know that 1 and 2 are true. So now you've narrowed it down to E. When 95% of the confidence interval is constructed, those confidence intervals would include a 0 95% of the time, and that would be absolutely true as well. If the true difference between these two is absolutely nothing, then if we created a confidence interval, 0 should be in here 95% of the time. And so I'm going to select E. Thank you for joining us.